Hello everyone, welcome back. In today's video, I'm going to discuss about starting of DC motors. The speed of a machine has to be increased from 0 and brought to the operating speed. This is called starting off the motor. The operating speed itself should be varied as per the requirement of the load. This is called speed control. Finally, the running machine has to be brought to rest by decelerating the same. This is called braking. At the instant of starting, rotor speed n is equal to 0. Hence, starting armature current IST will be equal to V divided by RA. Since armature resistance is quite small, the starting current may be quite high. That is, many times larger than the rated current. A large machine characterized by a large rotor inertia will pick up speed rather slowly. Thus, the level of high starting current may be maintained for quite some time so as to cause serious damage to the brushes or commutator and to the armature winding too. Also, the source should be capable of supplying this large current. The other loads already connected to the same source would experience a dip in the terminal voltage every time a DC motor is attempted to start with full voltage. This dip in supply voltage is caused due to the sudden rise in voltage drop in the source internal resistance. The duration for which this drop in voltage will persist once again depends on inertia of the motor. Hence, for small DC motors, extra precaution may not be necessary during starting, as large starting current will very quickly die down because of the fast rise in back EMF. However, for large motor, the starter is to be used during starting. A simple starter to limit the starting current, a suitable external resistance is connected in series as shown here. The starting current IST becomes V divided by R plus RA. R is the starting resistance. At the time of starting, to have sufficient starting torque, field current is maximized by keeping external field resistance to 0. As the motor picks up speed, the resistance value is gradually decreased to 0 so that during running no external resistance remains in the armature circuit. But each time one has to restart the motor, the external armature resistance must be set to maximum value by moving the jockey manually. Now, if the supply goes off, motor will come to a stop position. All of a sudden, let us imagine the supply is restored. Then, full voltage starting is applied. In other words, one should be constantly alert to set the resistance to maximum value when the motor comes to stop. This is one major limitation of simple rheostatic starter. There are also other types of starters available. We will see that in the other video.